What is the simplified form of each expression? Let's now solve B. In B here, as we said yesterday, we have square root of 2a times square root of 9a cubic. So the first step, I will put a consonant, or we can say like we have to distribute like 2a. Then I will put another square root here for 9. I will distribute also here a square root for a cubic. This is the first step. Then I will multiply now the constant with each other. Where's the constant here? We have square root of 2 and we have square root of 9. If we multiply them, we put 2 times 9. And then here we will put other variables and we multiplied them. So we have a and a cubic. Is it right?
Yes.
Yes.
Okay. This is now the first step. Then, now look at this one here. We have 2 and 9. So we can now distribute the square root, 1 for 2 and 1 for 9. And here a times a cubic, we write it as a to the power 4. Then square root of 2. What is the square root of 2? Can I find
Nothing.
it?
No.
Yeah,
No.
I can say I will keep it as it is. Square root of 2. What is the square root of 9?
3.
3.
3.
Now, let's come now to the square root of a to the power 4. I will now analyze it or factorize it to a to the power 2 times a to the power 2. Is it right?
Yes.
Yes.
Then I
Yes.
distribute it here like this and here. Then, as we said yesterday, this square cancel this and this cancel this. So I have a times a and 3 and 3 and square root of 2. So what's the final answer will be? It will be 3.
It will be 3.
The first time I will write the number. Then square root of 2. And here what did we have? A squared.
A.
Where did I have to write a squared?
Beside the 2.
No, here. I have to say
Beside the
3.
Beside the 3.
A squared square root of 2.
Teacher, I can say 3 the square root of 2, a to the power of 2.
Yes, you can say it also, but this is the simplified one. Oh, this is the order of them.
Okay.
Is it clear now?
Teacher? Yes.
Yes,
Teacher,
miss.
why I didn't
Yes, teacher.
multiply 2 and 9?
Sorry?
Why I didn't multiply 2 and 9?
You can multiply them here to write them as 18. Then you will factorize them to be 2 times 9.
So, teacher, you summarized the step, you made it.
Yeah, and I tried to skip this step to find the square root.
Okay.
Okay. Now let's do C. And C here, we have 7 square root of 5x times 3 square root of 20x to the power 5. Now here, I have 3 things. I have numbers without square root. I have numbers with square root. And have variables with a square root. So I will put now 3 brackets. The first one, which has a numbers only, 7 times 3. The second one, here, as we see before, this one, it can be written as square root of 5 times square root of x. And this one, it can be written as square root of 20 times square root of x to the power 5. Is it right? Like distribute the square root.
Yes.
So I will put now in the second bracket this one and this one. Square root of 5 times square root of 20. In the last part, I will put square root of x and square root of x to the power 5. Which are they? This one and this one. Is it clear now?
Yes, teacher.
Okay. Now then,
Multiply, no.
let's now
We'll
multiply
find out.
the numbers. Yes, 7 times 3.
It is 21.
21.
And 21.
Now, come here. Here I have square root of 5 times square root of 20. So I will gather them in one square root and I will multiply the numbers inside. 5 times 20.
100.
100, exactly. Times. Let's come here now. I will gather them in one square root. Now, x to the power 1 times x to the power 5. What I have to do with the exponents, if the variables are, they will be added. X to the power 6. Now then, 21, keep it as it is. What is the square root of 100?
10.
10, exactly. Times. Now, let's now come to this variable here. To this variable, we can say it's like this. You write it as x squared times x squared times x squared. Is it right?
Yes.
And
Yes,
if x is 2 plus 2 plus 2. Then we said that it is x squared. Let's kind of distribute the x squared here like this. So 2 cancel square root, 2 cancel square root, 2 cancel square root. So how many x's here we have?
3 x's.
3.
3.
So I would say x cubic. Don't say 3x. It's x cubic.
Yes. X
And then,
cubic.
what did we have here? Did I stop? Did I finish, I mean? No, I have here
No.
21 times 10. So the final answer is 210 x cubic.
Okay.
Okay?
Okay.
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 Now, I want to simplify the radical, and sometimes I don't know where or when should I stop. Should I stop at number 7 or number 24, or when can I know that I'm stopped correctly? That's here I should to stop. When you have radicals and you simplify it, you must have a big any number with square root of any prime number. Like the final answer, it must have prime number or square root of prime number, such as square root of 2, square root of 3, square root of 5, square root of 7, square root of 11, square root of 13, square root of 17, square root of 23, square root of 29, all the prime numbers that it cannot be factorized. So I can say I have 7 square root of 2, 3 or like 4 square root of 3. So if I must, or if I have to find or to finish with a square root of prime number. And sometimes I can have a composite number. I finished with a square root of composite number. But which composite number? A composite number that if you factorize it, you will find that it is a product of two prime numbers, such as 6. 6 is 2 and 3. So I can stop at square root of 6. And also, I can stop at square root of 10. Because if you factorize 10, you will say that it is 2 times 5. Because 2 and 5 are prime numbers. Or at 21, as an example. Because 21, if you factorize it, you will find that it is 7 times 3, but 7 and 3 are prime numbers. So I have to stop. Like, what also I can say? Like 14, square root of 14 as an example. 14 is 7 and 2. So they are, both of them are prime numbers. So where should I stop? I must stop at any prime number or at any composite number, but this composite number must be a product of two prime numbers. Let's have an example here to show you what I mean. As an example, I want to find the square root of 216. Now, I will ask myself, I have two ways. Either I can find the greatest perfect square, multiply by any prime number to get 216, or I will find all the prime factors. Let's now ask yourself, 216 is a product of which two numbers? Give me any two numbers that if you multiply them, you get 216.
Teacher, it's a product of 9. I mean, 9 is a multiple of 3, so 3 and...
Exactly, 3 is one of them. Thank you, Farah. Because Farah said that since the number or the summation of the numbers are a multiple of 9, so it can be divided by 3. So one of the factors are 3. Then Farah come here, divide 216 by 3. She said 21 over 3 is 7. 7, 20, 72, yes. Then, after that, a 72 is a perfect square number?
No.
No.
It is a number.
About another one. Now let's now try to factorize 72.
9 and 8.
9 and 8. Okay.
And factorize them, come on, also.
So here now, we have 9 and 8. We can come out to 8 now. In this 8, what did we have? What can we factorize into 2 and 4?
Square. Yes.
Now,
2 and 4.
So I have 4, I have 2. Now, since 9 is a perfect square, I can stop at 9. So if I factorize the number, or I use the tree and find any perfect square number, stop at it. Like here, I have 9, stop at it. I have 4, stop at it. But here I have 2 and 3. These 2 and 3, they are not a perfect square. They are not can be factorized. So write them here as 2 and 3. Keep it as it is. Then after that, I want you to factorize or to distribute the square root into the 4 numbers. Then, what is the square root of 9?
3.
3. Square root of 4?
2.
2.
2.
Square root of 2, I keep it as it is.
1/2.
And the square root of 3, keep it as it is. Then look at the final answer here. It is 6. Then
Square
here,
root
look at the 2 numbers here. Are they a prime numbers?
Yes.
Yes. So I can stop here. So I will say it is 6. Square root of 3 times 2, 6. And 6, as I told you, is a product of 2 prime numbers. I have to stop here. Is it clear?
Yes.
Yes, teacher.
But
Yes.
don't say, teacher.
Yes.
Now some of you
Yes.
says, okay, teacher, I will make it like this. Here, after they factorize this one, they say, teacher, okay, I will put square root of 9 times square root of 8 times square root of 2. Then, no. Okay, I say 9 is 3. Oh, she said, teacher, I will keep them like this. This is false. Because 16 is a perfect square or not a prime number. So I cannot stop here.
Okay, teacher.
Okay. Now, did you understand when I have to stop?
Yes.
Yes, teacher.
Now, as we said in the beginning of the lesson, simplifying the radicals, it can be done by 2 ways: multiplication and division. Multiplication, we know how. Today now, we will learn how can we use the division property to simplify the square root. They told me that, we know, all of us know that if you have a square root of a over b, it's like the multiplication. How can we distribute the square root on them? Here also, I can distribute the square root, 1 for the numerator and 1 for the denominator. So I can distribute the square root on the numerator and on the denominator. Let's have this example here. If I'm asked you now, what is the square root of 9 over 16? This one here. What we have to do? We have to distribute the square root, 1 for the numerator and 1 for the denominator. And then I will solve. What is the square root of 9?
3.
It's 3. And the square root of 16?
4.
This 4. So the final answer here is 3 over 4. This is, we called it the division property of square root. Now, when the radicand has a denominator like this one here, when the radicand, I'm talking about this example here, when the radicand has a perfect square in the denominator, so we can apply the division root of the division property of a square root first and simplify the numerator with the denominator. or can find distribute them. But if the denominator is not a perfect square, so I must simplify the fraction first. What does it mean? Look at these examples here. The first one. What is a simplified form of each radical expression? Look at 64 over 49. They told you the first thing. Look at the denominator. Where's the denominator? It is 49. Is it right?
Yes.
They told you if the denominator is a perfect square, so it's very easy. Just find the square root of the numerator. So let's now distribute the square root here and here. Sorry. So let's now distribute it on the one on the numerator and one on the denominator. Then, what is the square root of 64?
8.
8.
8.
And what is the square root of 49?
7.
7.
So the final answer is 8 over 7.
It's the simplest form.
Yes.
So teacher, we only find the square root.
Yes, for this one, since the denominator is a perfect square, so I just distribute the square root and find the final answer. Now,
Okay.
So for example,
if you have one
the
like,
root,
sorry,
the teacher, for example, the denominator is a perfect square number. So I distributed the square root on both the numerator and the denominator.
yes,
Then, like the numerator is bigger than the denominator, and I can they are divisible each other. So can I divide
sorry, Farah,
or keep it as a fraction?
I'm sorry, Farah, but do you mean if the denominator is a perfect square?
Teacher, for example, the square root is 16 over 2. Okay, I mean 16 over 4. I will distribute the square root, so it will be 4 over 2. Can I divide, because 4 divided by 2 will equal 2?
Yes, oh yes, yes.
Okay.
Talking about the simplified form. Now, if we have like in the denominator we have 49, and in the denominators we have like what do we have? Like 8 as an example. Okay. For this one here, we say that we have to distribute the square root for a numerator and for the denominator. Now for the denominator, it's easy. It's a perfect square number. So what is the square root of 49?
7.
7, exactly. Now look at the second one here. Square root of 8. Is there a square root for 8?
No.
No, so I have to factorize it into 4. Into 4 and 2, is it right?
Yes.
So then we distribute now come at the numerator. In the numerator here, as you see, we have a product of 2 numbers. So we can distribute the square root into 4 and into 2. Then
Square root of 4 is 2.
Exactly.
Square root of
Times
2
square root
over
of
7.
2 over what? Over 7.
7.
This is the final.
Over 7.
So it is 2 square root of 2 over 7. Is it clear now?
Yes.
Yes,
Yes.
teacher.
Okay. This is now the second case. Now look at the third case. In the third case, like if you have 32 over 200, and I want to find the square root for 32 over 200. But if you look at 32 at the 200, which is the denominator, as they told us here, okay, since the denominator is not a perfect square, so we have to simplify the fraction. Here, as you see now, the denominator is not a perfect square. So what did we have to do? We have to simplify the fraction first. How can we simplify the fraction?
Find one number that is divisible for both the
These two
numerator
numbers.
and the
Exactly.
denominator.
Exactly. As I told grade 6 before, let's start with number 2. Every time start with 2 and 3. Think about them. Let's try with 2 now. Okay, I want to divide
2 is small.
by 2
Okay.
by 2. Since we divide the numerator by 2, we have to divide the denominator by 2 also. Now 32 over 2,
16.
16.
16.
16.
And 200 over 2,
100.
100. Now look
100.
at the new numbers. Are the new numbers a perfect square?
Yes.
Yes.
Yes. So I will say they are 16 over 100. Then square root of 16 is 4. Square root
Over
of
10.
100 is 10. And we can simplify them also to be as 2 over 5. Yes.
Means teacher here,
we should
I will
always
not
simplify
find
them.
Yes, I'm told you, right? The simplified form.
Okay.
and teacher, when I want to simplify the fraction, I will not pick the biggest number that will be divisible by both numerator
You can,
and denominator.
yeah, you can make it like this. Divide it by 8.
4. Yes, 8 or 4.
Okay. By 8,
Okay.
by 8. 32 over 8 is 4. And 200 over 8 is 25. And then you distribute the square root. And you get the final answer as 2 over 5. As you want.
Okay.
If you think about 8 quickly, it will be easier.
Okay.
Okay, now. Now let's have this one here. Square root of 8x cubic over square root of 50x. Okay. Now here, as you see, we have variables and we have numbers, but these numbers are not a perfect square number. So let's now write them like this here. Let's first simplify the fractions. Give me a number that can be divided by 2, 8, and 50.
2
Let's try 2. Yes.
2.
8
2.
divided by 2 is what?
4.
And 50 divided by 2?
25.
25. Exactly. Then let's put now my new numbers. I have 4x cubic over 25x. So I simplified now the numbers, and alhamdulillah, I get a perfect square number. 4 and 25 are a perfect square numbers. Now let's come now with the variables here. On the variables, so I give like this. And on the variables, how many x we have in the denominator? 1 x.
One.
And in the numerator, we have 3 x's.
3.
So x cancel x. So
And then 2x will cancel the square root.
Exactly. So I have now to put like this. Square root of 4x squared over 25. Then let's now distribute the square root on the numerator and on the denominator. Square root of 4x squared over square root of 25. Then let's now come, I solve it in details. Now some of you can solve it quickly, shortly, without going or with these details. So I can say now this 4x squared, the square root, it can be distributed by 4 and x squared over square root of 25. Now what is the square root of 4?
2.
2.
It is 2. And this square root cancel the square, so we have x over. What is the square root of 5?
5.
It is
5.
So I have 2x over 5.
طب teacher يعني from the first to solve it quickly, when I come to 4x x times x over 25, I cancel the x with the x and still with me 2x's, so I will join them and cancel them immediately, so it will become 4x over 25 to become 2 over 2 over 5.
Yes, then we will simplify the fractions. Now some of you can make this from here, can stop here. Says, okay, طب ما هو 4 it is 2, 25 it is 5, and the square root cancel x, so they said 20x over 5 without making these steps. This is a shortly way.
Okay.
Okay. Is it clear now?
Yes.
Now let's do got it 5 here. In got it 5, what is the simplified form of each radical expression? Square root of 144 over 9, square root of 36 over 36a over 4a cubic. Now 144 over 9, I will distribute the square root for 144 and 1 for 9. I will say they are 144 over square root of 9. What is the square root of 144?
12.
12.
And the square root of 9?
3.
3. Now, since here the denominator is a perfect square, so I will find the perfect square of the numerator. Now 12 over 3 is
4.
4. So the square root of 144 over 9 is 4. Now let's do B.
Yes.
In B here, look at the denominators. Is it a perfect square?
Yes.
Look at the numerator. Square?
Yes, teacher.
That's
The
very easy.
denominator.
So I have 36 up and 4 down. Now let's come with the variables. How many A we have down? Up, sorry. We have
A,
one.
one.
And down,
3.
3 A's. A, cancel A. Then,
I have still 1A,
36
لا 2.
over 4
yeah. Now,
a squared.
what is the square root of 36?
6.
6.
6.
And square root of 4?
2.
2.
2.
And since here we have A squared, square root of them, they cancel each other. So how many A we have here?
1a.
1A,
1.
which is in the numerator. Then, over 2, let's simplify. Over 2 is 1, over 2 is 3. So the final answer is 3
Is 3.
over A. Is it clear?
Teacher, what
Yes.
did we do? In the last step, 6 over 2, how it became 3 over a?
So divide by 2, divide by 2.
Oh,
By
okay, thank you.
simplifying fractions. Okay? Let's do now number
Okay, teacher.
25. Number C, sorry. Or letter C.
Okay.
And C here, but I have only 1 minute. So I have to find, to solve C, then I have to stop. 25 y cubic over z squared. Look at this one here. In this one here, we have two different variables, y cubic and z squared. So let's now say it is square root of 25 times y. Or we can write it as y squared times y. The y cubic can be written as y squared times y times 25 over square root of z squared. Then I can distribute now the square root onto the 3 terms here. Square root of 25 times square root of y squared times square root of y over square root of z squared.